Hey everybody, it's Norm from Tested.
And it's Jeremy from Tested.
Welcome to Projections, our show about VR, AR, and the hardware and software that's going to put us in the virtual world. This week, we want to talk about hand presence and haptics.
Hand presence. Yes, this is something we didn't have for many years, isn't that true? With the Oculus DK1 and DK2, we were limited to head tracking only. And with the latter, only positional tracking, but that was it. And then, you remember the first experience I ever had with hand tracking, actual hand tracking, was Leap Motion.
Oh, interesting.
Right? Because they pivoted. They used to make a device you put on your desk and that would, see your hands or tools in, a computer space.
It would do a skeletal modeling of your hand based on some IR data.
But they pivoted to a VR company where you strap it onto your VR headset. And then that was the first experience I had with that. And I could reach into space and I could grab things and toss them, and it was like this wonderful taste of the future.
Yeah, I remember wearing gloves back at E3 like 3 years ago. Will and I did that demo. We were so excited. I think we didn't know about the potential of hand presence. These were just IMUs that we had to put on these gloves, sensors, basically your Wii Motion type sensors, and with calibration. But once we were in that experience, we were wearing astronaut suits and seeing each other.
Positionally tracked or no?
It was not positionally tracked. That's why you had the calibration.
Right.
But you had relative hand-finger motion and seeing the corresponding motion between what you know your hand is doing and what you actually see your hand is doing. It's very powerful.
Oh, absolutely. No doubt, which is what made this the best buy of 2016.
Yes.
Because Vive was the only place you could get tracked hand controllers.
Yes, and now we have hand presence on all the major VR platforms, but they all do it in a little different way. It's all abstracted because the controllers serve multiple purposes. On the Vive side, it can be a pistol grip, it can be a sword, and it can, based on where it thinks your fingers are, also abstract and show your hands for gripping things and grabbing things.
Yes.
Very light dexterity in games like Job Simulator. On the Oculus side, you have a little more powerful and stronger hand presence, I would say, just because of the way the grips are designed. They know more information about where they think your fingers are.
That's right. There's that finger tactile touching where if you put your fingers lightly down on a button, it moves your fingers around. So it does increase that presence. I would say, as we move forward into what this topic is going to be about, talking about these controllers, that there are triggers on these and buttons on these controllers, that's key. And I think that haptic feedback, even if it's not a rumble, but you can actually get a tactile sense of these buttons, comes into play in a way that makes these very, very compelling for the current state of the art.
And one of the things I think we learned is that you don't necessarily need a one-to-one movement for the hand presence to feel powerful or compelling.
Right.
With the grips on these controllers, for example, the grips are they're millimeters off the side of the controller, but you feel the feedback. You grip something and you release it. And in a game where you see your hand and you grip it and you release it with a trigger, that's not exactly what your hands are doing, but it's good enough that you know that you are having your action mirrored in the game universe. The next step, though, we think is something beyond a controller that you hold. Maybe something that you wear. And there are a bunch of companies trying to experiment with hand presence and haptics in a glove. There's Manus VR that we've seen a couple of times, and this is a glove that has a positionally tracked sensor on it. In addition to that, IMUs and sensors along that let it know how much your finger is bending. And they've created software to demonstrate that experience.
Yep, we tried that at GDC, and it's compelling. It's interesting. The Vive Puck does a great job at positional tracking, no surprise there. And the Flex sensors do a good job at showing you where your hands are. In general, holograms of your hands in front of you work wonderfully.
Yeah.
The problem, in my experience so far, has come when I actually try to reach out and touch something. Now, when I have a tracked hand controller and I reach out, I don't feel it, right? There's nothing there to feedback on my fingers. I try to pick something up and my fingers go right through it.
Right. Same with the Leap Motion. When you see your skeletal hand
Exactly right.
In front of you, yes, it is where you think it is, and you have some action. You can lift things up, but you're a ghost. You're a hologram.
You are, but you're a ghost that can interact with things.
Yeah.
So there's a disconnect. And the best things that worked with Leap Motion are the same things I find that probably work best with Manus, which is where I'm not supposed to be touching things, where I'm drawing like a magician, like I'm creating a shape with my fingers and then I'm tossing it out into space. That feels right because what I'm seeing is what I imagine it might actually feel like. I don't actually have to have anything pushing back on me.
Or games like The Unspoken, where you are a magician and you're just launching
Exactly
effects.
right.
And the gestures, where your hands are, where your fingers are, those are the things that you want communicated in the game that then determine what your spells are. But you're not actually holding anything tangible, physical, or tactile.
Right.
But a piece of hardware that we got to try recently from Dexta Robotics. This is something called the Dexmo. It's a exoskeleton that you wear for the Vive, and it has the Vive tracker as a positionally tracked controller, but it will potentially give you some haptic feedback. And the Dexmo Robotics engineers came by our office, they gave us a demo, and maybe it's best for you just to see what our experience was like.
So my name is Ayler. I am the CEO of Dexta Robotics, and at Dexta Robotics, we're building the next generation of virtual reality and mixed reality interaction device, which is this Dexmo that I'm wearing. It is a mechanical exoskeleton that you can put on your hand, and it kind of lets you feel the physical presence of virtual objects. You can feel the shape and the size and the stiffness of a virtual object.
Now, you talked about haptics and how a lot of people are doing haptics right now with a simple rumble motor.
Yes.
And they're calling that haptics.
Yes.
What is haptics to you that's different than, say, what you might find in an Oculus Touch controller or the standard Vive controllers?
Yeah, very good question. So for our device, we do a bit more than just rumble. When you're using a glove solution that has vibration motors at the fingertips and we're trying to grasp, say, a virtual apple, when your finger touches the edge of the apple, it vibrates. It does. But as a user, you can still kind of force your fingers to go through the virtual apple. And by the second you do that, you will realize it's not true. So the difference with our device is when you're trying to do that, the motors on Dexmo will actually pull back your fingers to fit the shape of your finger into the shape of that virtual apple. So your hands wouldn't be able to penetrate through the apple, and it will feel like as if you're actually holding it.
And you get unique feedback for each finger.
Yes, so they're all separated. We have 5 motors, and we have 11 degrees of freedom of tracking. So this device is capable of doing what most data gloves do, which is motion sensing. You can track the movement of your fingers, but on top of that, it gives you this force feedback that stops your finger from penetrating through objects.
So you can give a game engine or a computer information on where all your fingers are in space relative to the device itself.
True.
And then in order to track in open space, positional tracking of the full object, you rely on the HTC puck device, right?
True, but not necessarily just the HTC. So the global tracking is kind of a solved problem. There's a lot of solutions. Like, for example, the OptiTrack, and I think this is one of them. I think there was one that uses combine the inertia measuring units and the light optical sensing, and also gives you relatively good data. So there are multiple ways of doing it. The reason that we didn't do it is because we're focusing on something else that not everybody else are focusing on, which is solving the local force feedback and giving you a better presence of your hands.
So when you have this on, you should be able to tell what it is you're holding without even looking at it, potentially, right? I mean, you could do an experiment where somebody would pick up a cube and it would feel different than a sphere.
Yes, that is definitely true. But of course, we do suggest that with the proper visual guidance, it creates a better sensation. Because of course, these are limited. It doesn't do everything. For example, if you're touching a piece of wood and you're touching a piece of plastic, there's a difference. But with the glove, it's currently limited and doesn't allow you to do that. But of course, with the proper visual guidance and with a sound, say when you're touching the wood, it gives you that sound, and when you're touching a metal, it gives you that unique sound that metal makes, it makes you feel more realistic. So guidance help.
How far along are you guys towards a final product right now?
So right now, what you're seeing is called the DK1. What we just showed was already a version that we're capable of manufacturing and shipping. So I think manufacturing capabilities is very, very important in terms of hardware, because there's no point showing people something that you can only make 10 units a year. We're capable of making many, many more, and we're happy to distribute this to different people and see what they can do about it.
So tell me more about the actual sensors inside this device. Now, I understand that all of the fingers are tracked going this way, but they're also tracked going that way.
Exactly.
Is that right?
So,
But there's the motor control is only in this direction.
True.
This way is only tracking.
True.
That's right?
Yeah. So motor is where most of the weight is. And I want to make this device as light as possible. I know some people would still see this as a rather heavy device, but right now it only weighs around 270 grams. And compared to the past force feedback gloves, which used to weigh 5 kilograms, it is a huge improvement. And right now, the fact that these are wireless makes Dexmo unique. Nobody else can do this. So like you mentioned, about force feedback, we actually have only 4 degrees of freedom of force feedback, which is on each one of the fingers. But the tracking is 11 degrees of freedom. So there's a splitting of the fingers, and we have a good 3 degrees of freedom on the thumb.
Yeah, I noticed that the finger tracking was quite good in the simulation.
Yeah. So the reason being is that we're using rotational sensors, mechanically tracking the linkages.
Right.
So some of the other solutions are, some gloves are using IMUs, inertial measuring units, which...
The same kind of thing I'd find in my phone.
Yes, true. So the issue, well, the good thing about IMUs is they're very cheap. The bad thing is they kind of need to be calibrated, and they can be heavily affected by magnetic field or electronic waves or those kind of things, and they're not as reliable, to be said. There are also another type of sensors which are called the flex sensors, which is kind of something that you would see on a pair of data gloves that are much smaller. Issue with those type of sensors is that they have quite limited lifespan. That was kind of an issue that hasn't been quite tackled yet. And they don't give you linear data. So you kind of have to do a lot of mapping yourself. For us, because we know exactly what the skeleton of the device looks like, we know what a hand skeleton looks like, the mapping of our data with the virtual hand is much more reliable and easier.
Okay, so as far as the force feedback goes, you are able to only really pull in one direction from the fingertip.
True.
Is that right?
True.
So do you ever find yourself limited? Do you ever want to pull in a direction that you can't?
True. That does happen. But this is actually a combination of trade-offs. So the reason that we did that, we actually did, at the very beginning, we started with 10 motors. So we have motors over here and over here.
Oh, wow.
Yeah, and it gives you a very good, well, I think by that time we have 16 degrees of freedom for tracking, so 5 more, and 10 degrees of freedom of motor. And that does give you a very precise feedback of exactly where the directions are going, and you can apply a vector force to the fingertips. But then we also found that the weight of the device was just way over everybody's imagination. Every time they put them on, the first thing you hear is always, oh my God, these are so heavy.
Right.
So we couldn't do that. So we kind of cut them down, and we are limited to only 5 motors. And when we give the same test to people, they actually don't complain that much about how it doesn't feel so real, but there's no complaint about how heavy it was. So we kind of stayed at this design.
Right, interesting.
Yeah. A lot of the things went through separate iterations, so you can always validate.
There's probably a point of diminishing returns where if you have the 5 here, that's the biggest impact.
Yeah.
And then incremental changes above that become more expensive and heavier and don't have the return.
At the very beginning, I believe, when we were doing our Kickstarter, we knew that motors are the expensive parts. So we only had 2 motors on the index and thumb fingers. And we have massive amount of emails saying, could you please do 5 fingers? What am I going to do with 2? And then we thought about it. True. I mean, if you were to do actual shape simulation, what are you going to do with 2 fingers, really? Yeah.
So one of my favorite things was early on in the demo where you're pressing a button, and as soon as you feel the shape, you get a sensation, and you can push, and then you feel the click towards the end. And that's you're using the motors you're ramping the motor strength.
True.
So that I feel more of a sense of movement and popping.
So that was kind of the key algorithms that we're applying on these motors. So what you just experienced was called the double or multiple stiffness layers simulation. We're using these motors to kind of sending out a signal to let the fingers to feel for a certain amount of force on a certain amount of layer, but once you penetrate through that layer, the force changes and it gives you a different sensation. When you put that in combination with graphics, it gives you a very huge, tremendous sense of impact and makes you feel that this is very realistic.
Right.
There's a better way to address this. If you were to touch this piece of biscuit, the top layer and the bottom layer are actually quite hard, and the creamy layer in the center are soft. So if you can combine that with the multiple stiffness layer that this device is capable of applying, you can have a very realistic sensation when you're touching digital objects.
So when people want to implement that kind of feedback into their, say, games, all of your demos are based on the Unity engine, right?
Yep.
So someone were developing in Unity and they wanted to create that. Is that something that they can do on the engine side entirely?
They can do it very easily. So because we're actually shipping the device, of course we're not just shipping the hardware, it wouldn't make sense. We have a whole set of SDK already written up. And what developers have to do are very, very easy. You just need to drag our SDK add-on into Unity and connect up all the hardware properly. And pretty much that's it. Then when you go into that scene with the VR headset, you put on the headset, you'll be able to see your hands already. And then when you want to put an object in interaction with the hand, you just kind of apply different colliders to describe its physical shape, write on some scripts to describe how the object will deform and behave after you touch it. And that's pretty much it. Everything else are black boxed. The gloves will do most of the work for you. It will try to understand the geometry of it and which side of it should be pushed back and how your finger's supposed to feel. So we kind of minimize the amount of work that developers need to do. They don't even need to understand how the gloves work. They just need to build their things, build their games the way they want to.
And how accurate can those colliders be? I mean, if I'm grasping a complex object, can I actually feel the contours of a Vive headset, for instance?
I see. So that's a very, very good question. But again, because if we take a look at the gloves, they're actually just applying 5-point forces. So that question is heavily dependent on how close can these 5 points be. When we're talking about this, you can probably have a very good sensation. But when we're talking about something that's much smaller, say this pencil or this pen, you can feel this with no problem. But if you were to do, you can actually feel that as well. That's a bad example. I should probably use something that's more complex.
Candy cane?
Yeah, okay, this is a good example. So if you go like this, you will be able to feel it. But because this is very, very thin, you might be able to touch it, but it wouldn't be as solid. When you're touching a block, your hand wouldn't be able to penetrate through, but when you're touching a very thin cylindrical object, it can kind of slide through a little bit. So we would suggest to go with things at least this big. I don't know if that's precise now, but it's probably 2 millimeter by 2 centimeters by 2 centimeters by 2 centimeters. Roughly that size.
So I imagine part of your plan is to get these out into the wild and see what sticks and who the interested parties are. But do you have a vision of the most obvious, applicable?
Yes, definitely. So on our website, I already mentioned that we're very into the training area, the education area, the medical area, as well as gaming industry, obviously. So all 4 are viable. A lot of the consumers that are contacting us, and they were using this on their own projects for medical training. So
for medical training?
Medical training, yeah, for doctors. So a lot of the doctors...
How so?
I think doctors have a need of practicing their skills on virtual objects, or virtual patients, before they actually go into wild and operate on real people. So there are some procedure training where you're taking, picking up different objects and different type of tools. It is very important that you actually know what kind of tools you're picking up. when we're using the Vive controllers, I don't have it with me, but when you're using Vive controllers, when you're picking up different objects, it's probably almost the same. You're always pulling a trigger to pick things up, putting down by releasing the trigger. So it doesn't give you that much of a difference, and it doesn't build up that process of understanding what exactly should go here and there. But with the aid of this device, you can actually tell the difference between, okay, I'm using a pair of scissors, this is a screwdriver, and this is a saw for cutting somebody's leg, I don't know. And it does give you that sensation, and it helps with the memorizing of procedures and everything. So some of our customers are working in that area. And also training, we have people coming from the car industry and saying we could use to train our workers to build cars or disassemble cars more easily. Because when you're actually training a group of students to take apart a car, you wouldn't be able to let all of them to operate at one time. And you wouldn't be able to give every single student a car to disassemble because they're very, very heavy. But when you have a virtual interaction tool like Dexmo, you'll be able to kind of just put them floating in the air. You can disassemble the parts that you don't need and just get to the essence. If you want to look at the engine, okay, get rid of the rubbish, then take the engine, then you can look inside the engine. And it doesn't weight as much because it's all virtual. And also you can duplicate infinite number of them to infinite number of students. Which you can see the trend here, which is using only a small piece of software that you've written and you give it to everybody. That really cut down the cost.
Right. Well, haptics, I feel like are that's the next big great frontier for VR. Now that we have the visuals, and that's going to continue to improve and iterate. But now I want to feel that world, and I feel like this is the first really good step in that direction. Where do you think this is the tip of the iceberg for haptics? Do you guys have a vision for 5 years from now that's beyond the capabilities of today?
Okay, so that's a good question. We actually thought about, let me come back to you by some of the questions we've been asked. A lot of people came back to us and say, will you be building a robotic arm? The suits that goes here and goes to the leg. We probably won't actually, because that's not how we see technology goes. It has to be perfectly balanced. It can't be too complicated. There must be a balance between how much it offers and how much effort it takes to be put on. So for example, when we're using the Vive controllers, they're easily put on. You can just pick them up, put them down, but they offer a kind of, I don't know, a normal kind of sensation that you would expect. But when you were to put on a pair of gloves, because you took the effort of putting something extra on you, you would expect them to be really, really good. If it's just 20% better, why are you even doing it? You could just have used the controllers. So when we're using the exoskeletons, it's kind of the same thing. If you're doing this whole arm thing and you're feeling very heavy and clumsy, and it kind of just make you feel a little bit better, there's not much of a use of that. So that's why we decided, hands, that's the most important part of a human body. Let's crack that first.
And the whole hand?
Yes, rather every little piece about
Well, compared to touch, if I use the Oculus touch controller, it's binary. I can put my fingers down and up. With this, it's everywhere in between.
Yeah, you can see everything about your hands. So, I tried the touch controllers. They're very good as a controller, like I said. But when I'm trying the bullet train, when you're picking up an object, I think most developers are still using the snapping technique, which is you move your hand closer to an object, then the object automatically flies into your hand. Because most people haven't actually tried out to have their hands in VR and do what you just experienced, they kind of feel like that's good enough. But us, because we've been working with hands for a long time, 2 years from now, we can see there's a huge improvements. There are some huge improvements that can be done. For example, the snapping was definitely not ideal if you want a realistic sensation. You could have just go and grasp it, and it will move with your hand, and everything would be much better.
Well, congratulations on reaching your first DK phase. I understand you guys just won a Red Dot Design Award. It's obviously it's a cool device. It definitely looks very, very futuristic.
Thank you very much.
Congratulations on reaching this.
I'm very proud of the design as well.
Well, good. I wish you guys the best of luck.
Thank you very much. Handshake. Thank you.
All right, Jeremy, so maybe we should explain exactly how this worked and what it felt like using this, because the Dexmo looked so futuristic and sci-fi.
I might even say its look is the best thing about it.
Oh, whoa. Okay.
No, it looks really cool. I
Yeah.
mean, it looks like something out of iRobot.
Yes, I mean with a polished white plastic.
Yeah.
And so what they're trying to do there is have two things go on. One, they need to have this exoskeleton and it loops around each of your fingers. And that, when you move your fingers, moves their robot arm, their exoskeleton, which lets the system know where your fingers are relative to each other. That's for the tracking aspect.
That's true. There's actually 10 sensors on each glove. So they can track your fingers going this way, but they can also track this way.
Which is really important.
It is for accuracy, absolutely. And all of that is represented in virtual space as best as I've ever seen it represented. The tracking is excellent.
Yeah, and the virtual hands they had, where you could make a fist, you could have the fingers up and down. There was a little bit of drifting on their software. I mean, it's using the Vive tracker for its positional tracking.
Right.
But for the most part, what they've shown was in line with what I thought my hands were doing.
There's a little bit of resistance when you move your fingers around, but it's something that you just accept as part of the deal.
Yeah, and resistance, the actual feedback part that's the secret sauce for this Dexmo product, which is the haptic feedback. Now, haptics, the sense of touch, on a lot of these controllers and even your standard game controllers, your Xbox controller, PS4 controller, a lot of haptics come in the form of vibrations. The haptics on your iPhone, for example, your smartphone, it's vibrations. Yes, they have new haptics on, for example, the touchpad, which feel like it's a little bit of pressure where your finger is.
It's all a version of Rumble.
Yes.
Ever since the Wave controller, the Nintendo 64 Rumble pack came out, like that's what we've had in games and in VR for the past 20 years.
And what the Dexmo seems to be offering is not Rumble. It's actual resistance in the form of a motor. There are 5 motors in each of the hands, one for each finger. And based on their software, if the software thinks that your finger in that position should be feeling resistance, it will pull your finger back and prevent you from moving forward.
That's the great promise of this product.
That's the promise of the product. So one of the demos they showed was you pulling your hand out and they would have different shapes in front of you, like a ball, a sphere, or a cube. And you would be able to move your hand around the virtual object. And I tried this with my eyes closed and see if I could recognize, is this a sphere? Is this supposed to be a hard edge of a cube? And move my hand around that? And it took a little stretching of the imagination. I really had to push my brain to see and feel what they wanted me to feel. But once I got there, yeah, I could see what they were going for. It wasn't as accurate as I had hoped for it to be, but the algorithms were almost there.
Yeah, I think a lot of that has to do with the fact that you're always going to be colliding with things. It's impossible for those motors, at that size, even if they were stronger, to keep your hand from going through it, because they can only control your finger muscles. They can't control the momentum of your arm, your wrist, any of that stuff.
And I think for safety, they don't want to put extremely strong motors.
Right.
I mean, one of the questions I think you probably get a lot is, what happens if the motors go haywire? Going to mangle your fingers? And no, if you make a fist, any reasonable person making a fist can overcome the strength of the motors.
Right.
So it's really about relative resistance. And I had to train my brain and my fingers to not try to push too far, just to be very gentle with the moving around the edges.
That's it.
Let the motors push against my fingers. The only contact point this has are on the tip of your fingers. So you're not feeling the full haptics all in the palm of your hand. It really is just about the resistance moving on the top of your fingers. And it's not easy.
Well, the way that it connects is using this hinge that comes up. So they can pull your finger up from any direction. It's a good design. But my problem was that I couldn't get that sense of a shape. I wanted to run my finger around something and feel the edge. And it was never clear to me how I was supposed to do it. It was almost like, I feel like if I could spend more time with the unit, I could learn its limitations and really start to get a sense of what it can do, and then work with it. Because I want that haptic feedback so badly. Like that is something that I feel like is the next huge frontier for VRs. Once we crack that nut, it's going to be a new level of immersion.
Now, did you feel like them having just 5 motors for each hand was a limitation, even though our hands are able to move in more than just 5 different axes or fingers?
I don't think so. I mean, I think eventually it will expand beyond that. They said that their initial prototypes actually used 10 motors, but that they thought it was overkill. And in fact, a lot of their users or people who were pre-ordering the product said, please just make a 5-motor version for us, because that makes a lot more sense, a lot more bang for your buck, if you will, at that level.
Yeah, some of the other demos we use allowed for interaction. A lot of their demos were around the idea of a disassembly, pulling pins out and grabbing blocks. And when I trained, again, my experience, I worked with the program within their limitations to just pinch and pull. I felt the resistance was compelling. Like, I had the virtual bicycle in front of me, and I pulled the pin out, and I knew I wasn't going to try to grab it and manipulate it and be as dexterous as I would be in the real world. But I worked along with the system. I felt that haptic system working.
I think that's what you have to do, at least right now. And this is super early, right? Like we used it before it was on the market. I mean, you do have to work with the system, and I think if you don't, you're going to fight it. And so I think I was trying to just go at it and be a monkey and just like grab things, but you really have to be deliberate about what the limitations are of the software and the hardware, so that you do what it expects you to do. Now that couldn't be a good thing, because maybe these are software problems. Yeah. And maybe some of the immersion, constraints that I was feeling can be solved with improved drivers for the actual product, and they can iterate that without having to change the hardware.
I'm so confident in our brain's ability to adapt to these relative experiences. I bet if we spent more time in them and train our brain to work with systems, it's all relative. I don't feel like I need to feel like I'm holding onto a concrete ball that I can't move my fingers in, but I'm convinced that I can convince my fingers that I am holding on something if, based on how much pressure relative to what one finger is getting versus the other finger, like that relative feedback is enough to feel like I'm actually touching something in the virtual world.
Yeah, I feel like I want that Ready Player One experience.
Yeah, we
right?
Yeah.
I mean, that's the dream. It's like, if we're going to be in VR, we want our whole bodies represented in VR. We want to be able to reach out and interact with things. Yeah. But my takeaway from the recent experiences of hand tracking is, right now in 2017, be careful what you ask for.
Right.
Because we don't have the ability to really give enough feedback.
Oh my gosh.
While we have great tracking, it's that haptic feedback that is a ways out.
So be wary when you see Facebook videos of people trying to tout full body haptic feedback systems that you feel the blow of a sword. You know what? That just might be a rumble pad.
I'll be first in line to try it.
Yeah.
I want it.
It's still going to be a little ways out, but we commend the group here for experimenting with it. I think they have the idea of something there. They just need to refine the demo experiences, the software, and really make it a good product. But you know what? This may not be for consumers. This may be for professionals. I think the medical field could benefit from this. Maybe perhaps motion capture, performance capture.
Definitely.
And so it's just another part of the VR development history.
Yeah, and I wonder if really the tracking is the killer app for this kind of device, and it's not so much about that feedback.
Yes, that's something that, as we mentioned, Manus VR, not about haptic feedback, but what it means to have full finger tracking, or maybe a non-glove solution, a purely optical or a purely a vision sensing system like the Leap Motion, where you don't need, it's all model based, it's all abstracted based on its sensing of your hands relative to your head.
That's right. Leap Motion suffers from occlusion problems that they are trying to solve with their drivers. So that's one thing that this device easily gets around, because it's a full-fledged device itself.
Yeah, all of these demos, all they do is make us dream of what the next full big mass market VR product, what HTC and Steam VR are going to do next, what's Valve going to do next, what Oculus may do next. Down the line, a couple of years from now, we want that future now.
It's the early days.
It is the early days indeed, and thank you for following with us on the early days. We'll be back next week with more discussion about hardware and software topics in VR. But in the meantime, subscribe to our YouTube channel, like this video, and Jeremy and I will see you next time.
Bye-bye.